I'm F1, Mr. Brunt here. Uh, in this video, I want to give you an introduction to graphing, and I really want to ask you to stick with it through the entire video here. You may think I know how to graph, but I've found over the years that a lot of students, even some of my seniors in pre-calculus or calculus, don't fully understand what it means when we're graphing something. Okay, so I'm going to start with something relatively simple, and I want to just talk about the equation y equals 6. Okay, and what a graph does is it gives us a physical picture of all the points that will make this a true statement. So I'm just going to list off a few points that make this true. Okay, the point 1 comma 6 is true for this equation because my y value is 6, or maybe negative 2 comma 6, or 3 comma 6, or 6 comma 6, or 0 comma 6, or maybe negative 15 comma 6. All of those points make this equation true because their y value is 6. 7 comma 2 does not make that true. It is not a solution to this equation because its y value is not 6. So I don't include that point. And so what we do is we typically just graph in the xy coordinate plane here. And I'm just going to start plotting all of these points. And I'm not going to do a great job. I don't have graph paper here. But I'm just going to start plotting these points. Here's 0 comma 6. And here's 1 comma 6. And here's a negative 2 comma 6. And here's 6 comma 6. And here's 3 comma 6. And negative 15 comma 6 is way over here. And I think those are, a lot of the points that I just named. And after we start plotting all those, and I could come up with a whole bunch of other ones. Here's 5.3 comma 6. And here's 10.5 comma 6. And after I graph all the points I can think of that make y equals 6 a true statement, a shape starts to appear oftentimes. And in this case, it looks like all of those points happen to lie on a line. And so the solution to this, now, because I can't plot every single point that will make that a true statement, because there's just going to be an infinite number of those points. But then we look and we see the pattern, we say, oh, you know what? I think if I were to just draw a line through all of those points and then extend that on forever and ever, because I could get out to 10,000 comma 6 and negative 2 billion comma 6. Every point on that line is a solution, is something that will make this true. So that's what it means when we graph something. We are showing physically, graphically, all the possible points that make that a true statement. Okay. Now maybe this one was something, maybe that's too simple. Maybe that's kind of obvious. Maybe some of you are getting bored already. But again, just kind of stick with me because there's a reason we're talking through all this stuff. Okay. So let's think about the equation. How about y equals x plus 3? Now we've learned how to graph that. We've learned to look at that and we say, oh, that looks like it's going to be the equation of a line. That's in that slope-intercept form. That's a y equals mx plus b. I can find my y-intercept. I can find my slope, and I can graph that. Okay. But I want us to think about, what do all those points mean? How do we come up with that graph? And so again, just like we did up here, I'm going to come up with a bunch of points that make this a true statement. Okay. And so what this says is, I want all the points where when I find an x value, the y value is going to be 3 more than that x value. Okay. So for example, 1 comma 4 is a solution to this equation here. That makes that a true statement. When you put 1 in for x, yep, and you put 4 in for y, you get a true statement. You get 4 equals 1 plus 3. And then I have 2 comma 5. That's also a solution. That gives me a true statement on that. And then I could have 7 comma 10. Or I could have negative 3 comma 0. If I let x equal negative 3, negative 3 plus 3 is 0. So negative 3 comma 0, I would have 0 comma 3. I can have negative 10 comma negative 7 is a point. Negative 8 comma negative 5. I can have 20 comma 23. And you can see there's certainly a pattern there. And the pattern is anytime you look at your x value, your y value is just 3 more than that x value. Okay, but again, there's an infinite number of these. I can't list off all of them. But if I were to graph this, and again, my graph is not accurate in any way, shape, or form here, but if I started plotting these points, I said, well, here this kind of looks like it's the point 1, 4, and this looks like it's the point 2, 5, and here's that point 7, 10, and here's -3, 0, and here's 0, 3, and -10, -7 is way down here, and -8, -5 is right there, and 20, 23 is way up here. And after I plotted all the points that made this thing a true statement, I looked at that and said, oh, it looks like every one of those points seems to be lying on this line. And I could kind of generalize all that by putting a line, drawing this line through all those points. And what we would find is that any points, any combination of x and y that make this a true statement are going to somehow fit on that line somewhere, and vice versa. If I pluck off any point from that line, if I just look at that and say, I wonder what that point is, oh, you know what, that looks like it's the point 12, 15. Is this going to make that a true statement? And I would find out, yeah, it is. Okay? Let's try a couple more here. So what if we look at y equals 1/2 x? So again, just thinking about points that will make this true. This relationship says, in words, that the y value is going to be half of the x value. So if I start with 10, let's see, if the x value is 10, the y value would be 5, 10, 5, and maybe 6, 3, and maybe 7, 3.5. And I could have -2, -1, and 0, 0, and 18, 9, and 1, 1/2, and -1, -1/2. So I'm just picking a bunch of random points. And once again, when I plot all of those points, hopefully we see some sort of a pattern here. It won't always be an obvious pattern for all of these, but that's what we're going to see here, I think. So 10, 5 is somewhere way out here, and -2, -1 is somewhere down here, and 1, 1/2 is right there, and here's 6, 3, and 7, 3.5, and there's 0, 0. And if I just start plotting all of these points here, again, I see, oh, these all happen to lie on a line. So that's why we've learned how to pick out the important parts of this. We've learned how to say, oh, this is a y equals mx plus b. So this has a b value, a y-intercept of 0. It has a slope, a rise over run of 1/2. So it's going to graph into that. But again, the reason it graphs into that is because these are all the points that make that equation a true statement. And really, really understanding that is a hard thing for students to do. And once you really get that down, I think a lot of graphing in mathematics makes more sense. Okay, I'm gonna do just kind of one more quick one like this. How about the equation x equals -4? Again, thinking about all the points that would make that true: -4, 2, -4, 0, -4, 7, -4, 1. Any point that has an x value of -4. And if you think about it that way, you just start plotting points. Say, oh, here's -4, 2. Here's -4, 0. Here's -4, 7. Here's -4, 1. Here's -4, -9. Here's -4, 12. And it looks like all those points are on this line, this vertical line, where all the x coordinates are -4. Okay, so what I want to do now is I want to kind of jump back to when we were just graphing on a number line. So, so far our first 4 examples have all been on an XY axis. But what about when we were just graphing on a number line? We dealt with some inequalities on that number line. And let's say I'm dealing with the inequality x is greater than 3. Okay, and so here's where 0 is, and I'll put 3 there. Remember, we talked about 3 being a boundary point. And let's just think about, now it's not x's and y's, it's just x's. Let's talk about just some x values that will make that a true statement. Okay, so will x equal 4, will that make this a true statement? Well, 4 greater than 3, absolutely. How about x equal 10? Is that a true statement? Sure thing. How about x equals 13? Is that a true statement? 13 greater than 3? Yes. X equals 5.7. Is that true? Yes. X equals 9.14. Is that a true statement? Yes. I'm going to start listing off a few that don't make that true, things that will make that false. So these were all true statements. How about when x is 2? Is 2 greater than 3? No, that's a false statement. X equals 0. 0 greater than 3? No, false statement. X equals -1. Again, a false statement. X equals 0.14. Nope, false statement. X equals -8. False statement. And so if I plotted on my number line, well, let's see. Here's x equals 4. Here's x equals 10. Here's x equals 13. X equals 5.7. X equals 9.14. Those were all these true statements. And then my false statements, like x equals 2, that was bad. X equals 0, that didn't work. X equals -1, that didn't work. X equals 0.14 didn't work. X equals -8, that didn't work. And what we see was, oh, anything over here on this side to the right of 3 gave me a true statement. Anything to the left gave me a false statement. And so the way that we showed that is we put an open circle at 3 and then we drew an arrow to the right to indicate every point over to the right side of 3 is going to give me a true statement on this. And then we didn't include 3 because, well, let's figure out if I let x equal 3, does that give me a true statement or a false statement? That's going to be false because that would say that 3 is greater than 3, but that's not true. All right, so one more time, just to kind of look at this on the number line perspective. What if I were dealing with the inequality x is less than or equal to 5? And here's 0. I just like putting 0 on there, and 5. And again, if we just started listing off all the things that would make that true, x equals 2, x equals 4, x equals -8, x equals 0, x equals -1.9, and then some things that would make that false. X equals 6, that's false. 6 is not less than or equal to 5. X equals 10, x equals 7.2, x equals 19, x equals 5.4. These are all false statements. X equals 5, think about that real quick. Does that fit into this category or that category? Does it work or not work? X equals 5. Sure enough, 5 is less than or equal to 5. So we would include 5 in that. So if we just start plotting, okay, so 2 worked, 4 worked, 5 worked, -8 worked, 0 worked, -1.9, all of those worked. X equals 6 did not work, 10 didn't work, 7.2 didn't work, 19 didn't work, 5.4 didn't work. And what we find is, oh, everything that worked was starting at 5, including 5, was off to the left. So that is what graphing does for us. And I'm kind of pointing those things out because that's leading into our next video. How do we combine those two ideas of, figuring out, okay, I graph a line that looks like this, or maybe that looks like this. What if there's an inequality involved? How do I graph that? What does that graph even represent? And we'll look at that in our next video.